We have two problems here that are similar to the ones you did on the test, and I'm going to work these just to help you understand maybe if you made some mistakes, what you did. So the easiest way to do this, and remember that the instructions were to write these in exponential form. So meaning we're going to have fractional exponents most likely. And I see here that this first problem, first of all, let me say the difference between these two problems. This problem right here has everything inside the radical is in a parentheses, and this exponent of 2 applies to everything in the parentheses. However, this one is not in parentheses, and therefore this exponent of 5 right here only applies to the b, not to the 512. Now, the radical applies to everything inside. So keep that in mind as you work in these. So I am going to, first of all, rewrite this problem using exponents. So I have 64b, and it's squared, and we're taking the cube root of it. So if we convert this to an exponent, that means we have 64b to the 2/3 power. Well, so I'm going to write this now as two separate factors that are both raised to the 2/3 power. I'm separating the 64 and the b. It's easier to work with because I'm going to look at this 64 right here, and I'm going to say, I bet that there's something that might have be a perfect cube, because since the index here is a 3, we're looking for the cube root of something. So let's do a factor tree with 64 and see what we come up with. All right, so I know for sure that I can take, well, let's just split this up into 8 times 8, because we know that 64 is a perfect square. And each of these, of course, is a 4 and a 2, a 4 and a 2, which of course is a 2 and a 2 and a 2 and a 2. Therefore, we can see here that we have 6 2's, and therefore we have 2 to the 6th power. So what I'm going to do is I am going to write 64. I'm looking for a cube root. Well, this is something to the 6th power, but couldn't I also write this as 2 squared to the 3rd power, because we know that that means we'd multiply this 2 and the 3, and that would give us 6, and which is exactly what I have here. So I could write this as 2 squared to the 3rd power. So this 64 right here could be written as 2 squared to the 3rd power, and actually 2 squared we know is 4. So we could write this as 4 to the 3rd power. So 4 to the 3rd power. And why would I want to do this? Well, I want to do this because I'm looking for a cube root of something. So I have 4 to the 3rd power raised to the 2/3 power. So since I have something to the 3rd power and it's raised to 2/3 power, these powers will multiply. I will have 3 times 2/3. That's going to give me 4 squared. All right, so I'm going to simplify 64 to the 2/3 power to 4 squared, which we know is 16. We're going to go ahead and bring down this b to the 2/3 and b to the 2/3. And therefore, I'm going to write my 4 squared. I'm going to simplify that and write that as 16b to the 2/3 power. Okay, so you have to keep in mind what that index is and try to find something times itself that many times. And of course, you may have leftovers. So let me show you what I mean by that. Let's look at this problem right here. This 3 out front, well, you're just going to leave that there for now, and then you're going to see at the end if you know what you're going to do with it. And as I said, everything in here under the radical, 5, 12, b to the 5th power, is being raised to the 1/4 power. And now I'm going to simplify that again. 3 times 5, 12 to the 1/4 power, and b to the 5th to the 1/4 power. And I'm going to rewrite that as 3 times 512 to the 1/4, and b to the 5th power to the 1/4 power is b to the 5/4 power. Now that's simplified. There's nothing I can do with that. But I'm going to look at this term right here, 512 to the 1/4 power. Are there any factors of 512 that would be times themselves 4 times? Well, let's just do a factor tree on 512. I'm going to do 2, and then that's 256, and then that's, well, that's 2 and 128, and then that's, let's just take a 4 out of here. That's 4, and that would be 32. And we know that 32, I don't need to keep going with that because I know that 32 is 2 to the 5th power. So I'm going to have a 2, a 2, a 2 to the 5th, so that's 2 to the 7th. Wait, I forgot this 2. 2 times 2. So it's 2 to the 5th, that's 2 to the 9th power. Okay. And I said that we're looking for something multiplied times itself 4 times. Well, I have 2 things multiplied times themselves 4 times because I can multiply 2 times itself 4 times and then 2 again times itself 4 times. Well, that really means that I have 4. 2 to the 9th could be written as 4 to the 4th power, right? Because that would be 2 to the 8th, and we still have 1, 2 left. So I have 4 to the 4th power times 2 would be the factors of 512. So I'm going to write 512 differently. I'm going to say 3 times. Instead of writing 512 to the 1/4 power, I'm going to write 4 to the 4th power to the 1/4 power times 2 to the 1/4 power. I'm factoring 512 to 4 to the 4th and 2. Now, if you wanted to multiply these out and see if that in fact gives you 512, you could do so, and you would see that that works. It's always a good idea to check those things. All right, and then we have b to the 5/4. Well, 4 to the 1/4 power is strictly going to be 4 because you would multiply 4 and 1/4, and that would be 4 to the 1st power. And I still have this 3 out here. And now I have 2 to the 1/4 power, and I have b to the 5/4 power. And this is a base with an exponent. I have no matching 2's bases to combine with that, but I have some numbers here that I could certainly multiply, and that's going to be 12 times 2 to the 1/4, b to the 5/4.